Raise your hand if you're feeling declarative. It's okay. Declarative just means good. All right. That seems to be the consensus. Mr. Piano here, he says that declarative is code you like and imperative code is code that you don't like. I've heard developers describe declarative versus imperative as sort of like a what versus how question, where declarative is what and imperative is how. But that never really resonated with me. To me, what versus how feels more like a level of abstraction distinction. So for example, you could have some imperative code like this snippet at the top. It's really high level. It's just using an abstraction. And to me, that feels more like a what. And then you can have some really detailed JSX, which is declarative. And to me, that feels more like a how. So the most common way that people describe imperative versus declarative is something like this, where you have like a for loop and then you have array methods. So the for loop is more imperative and the array methods are declarative. Yeah, imperative is lower level here, but can you see another difference? I mean, there are a lot of differences, but the bottom one is part of a single declaration. So it's just one declaration right there. So that's what I think declarative code actually is. It's just declarations. And so this would be a declaration, and the const keyword isn't really necessary. You could be a class property and it's still a declaration. And the variable name is just used to refer to it in other declarations. So I don't actually think that's a necessary part of it being a declaration. You can have a template that has a header and it's declaring the header. This is declarative, but we don't need a variable name to declare this. So actually, I think that declarative code is declarations, which are descriptions of things. But it's a little more nuanced than that. I think this is another way you can declare or describe that same header, but there's something big that's different here. It's split up. The HTML is just declaring an empty header, and then the vanilla JavaScript is finishing that up and describing the inner text. And so I think declarative code is where each thing is described in only one place. And imperative code would be the opposite, which makes sense. Here in the imperative example, you have the same variable, and it's being defined in multiple places. First, it's defined as 0, and then it's defined as being added onto by elements in the array. So if declarative code is code that where everything is described in only one place, then imperative code is the opposite, where something is describing something else away from that thing's main declaration. And imperative literally means to command, and so that's something telling something else what to do. And that separation is what matters, I think. Usually there are command verbs used, like push, reverse, or shift, but syntax can be weird, and you can just think of imperative code as code that's modifying something that's declared somewhere else. So this is svelte and Angular 2A data binding. At least in Angular, it's not really clear that there's any kind of command happening, but this model, ng model, you can think of that as a verb. It's like model this, but regardless, it's code that's modifying something that's declared somewhere else. So this should be classified as imperative code. But React state is often controlled imperatively as well. Here, the count state is described as 0 in its main declaration at the top, but then more behavior is defined in the imperative set count commands in the event handlers. React actually isn't very declarative. JSX is, but React state usually isn't. Remember that React and Flux are two totally different things. They were introduced at the same time. This talk is a really, really important talk in the history of React. This is where Flux and React were introduced, but they're introduced together. And just out of curiosity, could you raise your hand if you use React at your main job? Yeah, that's what I thought it'd be. All right, so you should definitely watch this talk if you haven't, or rewatch it. And even if you don't use React, I think you should watch this as well, because this defined so many of the patterns in all frameworks. We have NGRX and Angular that's inspired by Redux, which was inspired by Flux, and it's all kind of getting at like the unidirectional data flow. This talk actually has 3 parts. Part 1 is hype, and then they go over Flux, and then React. And Flux was the thing that was described as unidirectional. React was described as the rendering framework. They actually use the word framework. So as originally described, Flux was meant to set the state in a unidirectional way, and then after that point is where React would take over and render in a declarative way. But if you look around on GitHub for some recent React projects, you'll see a lot of code that looks a lot like this. You have a lot of use states and a lot of event handlers that are imperatively setting those states. But guess where I got this code from? I actually just took this code from the example from that Flux talk. This was the example that Jing Chen gave to explain why MVC doesn't scale. This is a controller. This event handler is a controller, which means this, a lot of modern React code is MVC. So that makes it React and MVC framework. And we've got lunch after this, so if you want to meet down here and fight me, I'm a pacifist, so I just won't fight back. But anyway, so if you're controlling state and event handlers, you're using MVC. And in other words, you're using the same architecture that repeatedly caused the most annoying bug in Facebook history, the inaccurate unseen message count. Now, most apps, to be honest, aren't as complex as a chat app. They really aren't. It's just showing data most of the time. But if your app needs to scale to this complexity, you might want to hear what the Facebook team said about the problems they encountered. They pinpointed the problem at a thing they called external control. The event handler is responsible for too many out-of-context state updates. It needed to manage multiple states away from where those states were declared. And Jing called this external control. So they internalized the control. They co-located the state control logic with the state declarations themselves, and they stopped seeing the bug for good. Do you remember what it's called when something's co-located inside a declaration? That's declarative code. So when they introduced the single directional data flow architecture and declarative view rendering framework, they could have called it declarative state and declarative views. Here's another great talk in React history. In 2018, this was the hooks talk. It's common to use color to code what state is being controlled by each line of code. And yeah, so this on the right is with hooks, and on the left is with the old component lifecycle methods. So imperative code is organized by when it executes. If you're asking a question, why is this line of code here? It's because that's when it needs to run. On the right, you can group your code by relevance or concern. Every line of imperative code violates separation of concerns. Sometimes that's fine because other things can be more important. But as far as organization goes, imperative code is not ideal. So to kind of overview these differences here, imperative code looks like the thing on the left. You have a lot of callback functions or event handlers or controllers, and they contain imperative code that controls multiple external things. And declarative code looks more like the thing on the right. It references what it needs to define each thing, but the logic that controls it is all included in the thing's declaration. So let's go through some specific benefits of declarative code. First, it's less buggy. When everything is co-located in the same place that's controlling the same thing, you can reference other code that's also controlling that thing and iron out inconsistencies. It's easier to debug. So if everything's all in the same place, it's a lot easier to track it down. With imperative code, you need to find all references and load all of those references into your mind and keep that in your mind in order to track what's going on. And with declarative code, it's easier to understand. When you're editing a declaration, you can focus just on that thing and ignore the entire rest of the world because all the other code is doing the same thing. It's all minding its own business, just like this code. And that's part of the declarative mindset. You can just get used to focusing. So declarative can also be called a reactive state because the state is changing, but it's in charge of that change. So it's like the state itself is reacting. Reactive and declarative are the same thing, but reactive means it has to change because it's reacting. And it's also the same thing as unidirectional data flow. Reactive code flows in one direction. And it's a lot simpler than MVC, where code can change literally anything, anywhere, at any time. Imperative code is spaghetti code. So with all these examples, you might think I'm trying to convince you to use Flux or React, but I'm not. I have issues with Flux. One problem I've always had is it didn't really have a declarative answer for side effects. Redux, which is Flux-like, has also never had an answer for that, and neither have any state management libraries derived from that. But the bigger problem is Redux forces you to make a deliberate decision between local and global state because it uses a completely different syntax from how any framework handles local state. So recently, 6 months ago, Angular released signals. And that means now all the major frameworks use pretty similar fundamental primitives for handling state. And so you're going to have this problem with pretty much all of the frameworks. And so the more you develop with local state, the harder it is going to be to move to Redux later. So some companies will say, all right, we're just doing everything global store, but a lot of developers resent that because it means you have to use a lot of boilerplate for every little thing you have to do. So let's look at how that happens. Let's start with this simple component. You have a name, and then you have a button that can change the name. And let's say we need to add a button to reverse the name. And we can do that declaratively with useReducer, actually. But it's a lot of work. It's actually even more work than Redux. Redux is even more work than this. Okay, so the path of least resistance is to just add an event handler. But you can see, like I was talking about, this already splits the declaration of state into two places. That sets us down a path. So this is really unfortunate. The easy thing, the path of least resistance, is the thing that does not scale with complexity very well. And the thing that does is annoying. But what if we just start with imperative code and refactor later to declarative code? The tricky thing is imperative and declarative are as different as any coding styles can be because they're literally inside out compared to each other. So if you start down the imperative path, you set like a foundation where at every step of the way, it's going to be easier to add another line of imperative code rather than rewrite the entire thing, because that's what you'll have to do. So, right. I see two solutions to this. First is declarative code needs to be easier from the very beginning. We need tools that will simplify it, even for simple code. So one that I really like is tanstack query. This is an awesome library. I'm a huge fan of tanstack query. The first snippet here is use effect, a very traditional kind of imperative React code here, fetching data, imperatively setting state. Tanstack query is both declarative, it's one declaration, and it's simple. So I love that. Another important library, unfortunately for a lot of you, is RxJS. Look at all the operators. The learning curve is really steep, but the reason RxJS is important is because it allows you to write 100% declarative code in every situation. And it can be really simple. It depends on the problem you're working on, but it can be like a superpower once you're familiar with it. So this, for example, is a feature that's fairly asynchronous. And the more asynchronous your feature is, the more RxJS shines. So the left is the implementation in RxJS. The right is the implementation in Signals with Angular. And React would look pretty similar. Like all the frameworks are using similar state primitives now. So they're doing the same thing. So yeah. Signals aren't ready to replace RxJS completely right now. But the main point is RxJS can be the perfect tool for the job, and it can really save your code base from exploding in complexity. And last one I'll mention is one that I made. This is state adapt. I made it so that you could write simple code as declarative code. So in the bottom right, it's actually one line of code less than the imperative example in the bottom left we saw earlier. But by far the most important thing is to have a declarative mindset. And this is something that just gradually sets in, basically. But it means you know what declarative code is, you understand its benefits, and so you're motivated to always avoid imperative code when you can. This is a real example that I refactored. I have a YouTube channel where it's kind of my hobby to refactor random projects that I find on GitHub. And the imperative one is the one on the left, and the declarative one is the one on the right. So if you have a declarative mindset, you'll be able to code things that look more like the thing on the right than the thing on the left. All right, you can find me on Twitter at mfpairs and YouTube Mike Pearson Engineering 8793. So yeah, thank you.